this session, we're going to deal with number patterns. Now, these are actually probably the simplest part of the syllabus, really. Well, not always, but generally speaking, okay? It's not a difficult section, and there's a recipe again. There's rules that we follow here, all right? Okay, so first of all, let's have a look at number patterns. Number patterns. Okay, number patterns. What types have we got? We've got arithmetic. Okay, in essence, we're adding or subtracting, right? In other words, we're adding or we're subtracting to get our answer. 2, we've got quadratic. Those are new ones. Some of you may have seen it. Quadratic, okay? And in the third type, we have got a geometric sequence, right? Now, arithmetic, quadratic, and geometric. In essence, they boil down to this. Okay? Constant first difference, constant second difference, and no, not constant third. This one has got a constant ratio. Constant ratio between the terms, right? So in this case, it's a multiple. This is multiply or divide to get the term. These are basically plus or minus, and the quadratic is one of its own. Let us talk first of all, if you are given a pattern. Let us take, as if we've got an example. This is a hypothetical example, right? It's not just going to go through a little bit of a process. Minus 8, minus 12, minus 8, minus 12, minus 16, minus 20. Okay. Step 1 is you write it down and you put in T1, T2, T3, and T4. Those of you who did grade the previous work with me last year, or the previous year's work, that's the first step always. You write down T1, T2, T3, T4, T5. You write down what you're given, because we're going to find they're going to give us term 2 and 3 and 6. They're not going to give T1, T3, and T4. So here we're going to get into, you've got to write that down. It's the only way to move forward with these. So what do? I say, right, let us check, right? Step 2 is, can I write it over here? That's step 1. Step 2 is check first difference. So what do I mean by that? Let me just erase that. I mean the first difference is subtract T2 minus T1, T3 minus T2, T4 minus T3. Subtract the one ahead from the one behind. So rather, the one ahead minus the one behind. Okay, so in this case, we've got minus 12 minus minus 8, minus 16 minus minus 12, and minus 20 minus minus 16. Please watch out the brackets here, because the minus signs are horrendous. Yes, constant. Okay, it is constant. That means by itself. Therefore, it is a linear sequence, right? Which means it's arithmetic, as we used to know. It's a linear sequence, right? A linear sequence means Tn is equal to A plus N minus 1 times D. Once again, you can see I use the brackets, okay? If it was not constant, then you proceed to the second level. I'm going to do one of those, okay? So we can then fill in. A is what? A equals the first term. N is the term, the number. And D is the first difference. Okay? D is the first difference here. Okay? Now this is quite important, right? If it's neither, if we don't get a second constant difference, then we're going to try for a constant ratio, which is a geometric series, okay? Right. Therefore, in that one that we've had, we know that A is equal to, in this case, let me just go check. Come on. Minus 8. Minus 8. D equals minus 4. Therefore, the general term, this is the expression for the general term. So we fill in what we know. Tn A is minus 8 plus n minus 1. D is minus 4. Remove brackets. Minus 8 minus 4n plus 4, because that's going to go across there, isn't it? So therefore we end up with minus 4n minus 4. And from that point onwards, you can be asked two things now. You can be asked, therefore, what is term number, which is term number 8? Which means, if they say, what is the value of term number 8? They mean T, the N is the 8. So therefore T8 is going to be equal to minus 4 times 8 minus 4. Okay? Minus 4 times 8 minus 4 over there like that. And that gives us minus 36. How else can they ask us this? Well, they can ask it. They can say, or what or which term is equal to, say, a number minus 60. Which term? Which term? T. So therefore, T, okay, N is equal to minus 60 is equal to minus 4n minus 4. Therefore, N, you work out, and N in this case is going to be equal to 14. And can I check it? Of course you can. You go T14 is going to be equal to minus 4 times 14 minus 4. And you get minus 4 times 14 minus 4 is equal to minus 60. So can you see there's two ways. They're going to either give you that value, which is this one here, is it not? Or they're going to give you the red one. They're going to say, okay, is term is equal to, in other words, they're giving us that one is that. Can you see? That's the only two ways they're going to ask you this, all right? And then they're going to ask you a few questions about it, etc., etc. Okay, now let's have a look. Okay, let me just put my pen back. Come on. Pen back to black. All right. Please note, you can not have term 0 nor term minus 5. We start always from T1 and we go that way to Tn. Okay? You can't have T0 or T minus 5. Okay? Right. All right. Always read. No. Just another hint. Okay? Just another hint. Read the, I know you've been told this many times, read the question. Okay? Look to see if they say linear, quadratic, or geometric. Because if they say that in the verbiage, in the actual sum, you know which one you're dealing with. And each one's got its own specifics, right? Here's another question here, all right? They say, find the value of x in the following linear sequence. Whoa, they've told us. They say, example, find the value of x in the following linear sequence. That they've already then told us. What does that mean? It means Tn is equal to A plus n minus 1 times D, and it means first difference are all equal. Doesn't it? It means the first difference is all equal. Okay? Okay, say we are given the this. They say 3 terms are this, and the first term is this. Okay, 3 terms are that, and the first term is that. Okay, find the following sequence if it's linear. They've told us, but they tell us T1, T2, and T3. They say T1 is 2x minus 1, 4x minus 5, and 3x plus 3. Oh my word, they've now given us x's instead of numbers. Well, what do? What did the recipe say? Whatever you do, you put them down and then you check first difference. Okay, that's going to be 3x plus 3 minus 4x minus 5. This one is 4x minus 5 minus 2x minus 1. Okay, you with me? You've taken, what have I done? I've taken this one. Wait, let me just get my green. I've taken this one and I have subtracted that one. I took this one and subtracted the one behind it. Now be careful when you undo the brackets. This is going to be 4x minus 5 there. Okay, minus 2x. Okay, plus 1. This over here is going to be 3x plus 3 minus 4x plus 5. Now we're going to simplify that a little bit, and we're going to have, this is going to be equal to 2x minus 4 and minus x plus 8. What have they told us? They've told us it is linear. Linear means what? It means that the general formula is Tn is equal to A plus n minus 1 times D. It also tells you that this must be equal. This is first difference. They must be equal, right? So what do? I put them equal and I say, okay, put them equal and then solve for x. And I'm going to, out of this, get x equals 4. Then what do? I go back and I substitute back subs x equal to 4 in the sequence. Okay? Go and put it back. That's what you looked for. So if I put it back, I'm going to get T1 equal to 7, T2 equal to 11, and T3 equal to 15. Constant difference is going to be 4 and 4. And now, what do I do next? Next, I'm going to do, move my page down a little bit. Next, I'm going to say, right, therefore, it's linear. We knew that from the word go. Therefore, Tn is going to be A plus n minus 1 D, and it's going to be A is 7 plus n, we don't know, minus 1 times, what's D is plus 4. This gives us an eventual thing of 4n plus 3. So therefore, you can work out for any term, right? You can work out what it is, T5, or say if they tell us term 5, that's a 5 and that's a 5. Or if they tell us the term equals, then you would put that equal to what they give you, correct? Okay, now let's move on. Okay, now the recipe stays the same. Find the general term of the following sequence and what is T10. Okay, right? They say this is an example. Okay, find the general term, general expression, general term, look out for that word. Find the general term of the following, and they tell us T1, T2, and T3. 2 over 5, 5 over 4, 5 over 4, 8 over 3. Well, no, we've never seen anything like that before, right? What you do is they have a look at this. Can you see that basically what you've got there is there's actually two sequences involved? There's a numerator and a denominator, right? The numerator, okay? What is the numerator? The numerator is 2, 5, 8. Well, let's see. What's it say? T1, T2, T3. Let's check. That's going to be plus 3, plus 3. Yes, it is equal. Therefore, it's linear. Therefore, Tn is going to be A plus n minus 1 d. You're going to get sick of me saying that. So we say, right, therefore, Tn for the numerator is going to be 2 plus n minus 1 times d, which is 3. And if we work that out, Tn for the numerator is going to be equal to 3n minus 1. Now what do? We do the same for the denominator. Okay? The denominator is going to be T1, T2, T3. The denominator is going to be 5, 4, 3. So what do? Minus 1, and do the same issue. Okay? And we end up with Tn for the denominator being equal to 6 minus n. Therefore, T for the sequence, okay, is going to be equal to 3n minus 1 over 6 minus n. Okay? So therefore, what is T10? Put in 3 times 10. 3 times 10 minus 1 over, oh dear, that's just really not cool. 3 times 10 minus 1 over 6 minus 10. And we get an answer of 29 over minus 4, which we write as minus 29 over 4. Simple and straightforward as that. Okay? So, be careful. Sometimes we get that, right? Sometimes you get, you can even get, you can get different color tiles, right? Think about it. You could have this, right? A pattern that's got tiles in it that you could say, right, those are all around the outside, like so. They're all black tiles, and the one in the middle could be a red tile. So you've got a sequence. You've got a Tn for the red, okay, and you've got a Tn for the black tiles. So the total tiles, you've got T for the block is equal to T for the black, Tn for the black, right, plus Tn for the red tiles, isn't it? Tn for the black and Tn for the red, right? So if they ask you how many red will be in the fourth, you look at the red tiles as a sequence on its own. The black as a sequence on its own. For the whole lot, you add them together. If they want another black tiles, you've got a sequence for black and a Tn for black. Okay. Now, let us look at a quadratic sequence, right? Just follow this logic here. Quadratic sequence. Like that, okay? What am I saying? First of all, we write down T1, T2, T3, okay, and T4. Take the first difference. Always we write it down, take the first difference, and that's going to be, okay, take the first difference, and that's going to give us that, okay? I'm going to say that, for example, let us say the first difference comes out to be illustrative, -8, -10, and -12. So it is not constant. So what do we do? Well, next we do this. Okay? We take the second difference. We just move it down a bit. We take the second difference, which is -12 minus -10. -10 minus -8. And what do we get? We get -2 and -2. This means the second difference is constant. Constant, right? Therefore, it is quadratic. I am going to show you in a second. Therefore, if it's quadratic, Tn is going to be equal to an squared plus bn plus c. And we've seen that before. It's a quadratic in n. All right? Now, what do we do? There's a recipe. A is equal to half of the second difference. All right? So A is half of the second difference. It's not the first term in this case. So in this case, my A is going to be -2 over 2 is -1. All right? So we calculate A. This is step number, just number 5 or whatever. Calculate A. Okay. Oops, not in brackets. Calculate A and put into Tn. So we've got A, we know the number. So we're going to subs it in. Tn is equal to, in this case, -1 times n squared plus bn plus c, which is going to be equal to -n squared plus bn plus c. Right? And the next step, okay, just write these down. We're going to do them. Choose T1. It is known. Or T2. Find one that is known. T1 is always the easiest. What does that mean? If they said to us T1, okay, it's given. Substitute it in. So therefore, T1 is equal to -1 squared, right? Okay, plus B times 1 plus C. And we know this number here. I'm going to do an example, right? Then choose T2, do the same again. You're going to get two simultaneous equations with two unknowns. I am going to do a sequence. Let us look at this guy. 5, 10, 19, 32. Step 1, step 2, step 3. No, step 1, write down the sequence and label it. T1, T2, T3, T4. Let's see. 5, 10, 19, 32. 5, 10, 19, 32. Take the first difference and check if it's constant. 10 minus 5 is 5. 19 minus 10 is not. It is 9. 32 minus 19 is 13. not constant, therefore not linear, therefore go on. Check second difference. Check second difference. Right? If I do that, it's going to be 13 minus 9 and 9 minus 5, which is plus 4 and plus 4. Yes, it's constant. What does that mean? It means it is a quadratic sequence. Let me just make that look a little bit better. Sequence. Therefore, Tn is equal to an squared plus bn plus c. Right. Now, I know some of you have been taught a different method. Some of you, I'm going to get to that alternative as well. All right. I'm just doing it this way first for those that don't like the alternative or whatever. What do I do? Okay. Pick T1 and back sub. Plug it in. Okay. Plug it in. Okay. And in other words, we say T1 is going to be 5. So I say, using T1 equals 5, therefore I say 5 equals A. A I haven't got. Work out A. A is half the constant difference. A equals a half of 4, which is 2. So I'm going to put it in as 2. All right. 2. N is 1 plus B times 1 plus C. So therefore 5 is going to be equal to 2 plus B plus C. I am very sure that you can see where all this is going. And what do we say? We end up with B plus C equal to 3. I've just turned it around, right? Just to make it the traditional way we see simultaneous equations. What am I going to do next? Okay. Next I'm going to say, whoops, sorry, not that. I'm going to say using T2 is equal to 10, right? Therefore, n is 2 and the term is 10. 10 is equal to 2 times 2 squared plus b times 2 plus c. And we simplify that lot, okay? And we end up with 2 equals to 2b plus 2c, okay? 2b plus, 2b plus c, all right, is going to be equal to 2. My next step, okay, in these is to then say the following. I'm going to solve them as simultaneous, and I say that 2 equals 2b plus c. Okay, this is my one equation, and 3 is equal to b plus c. Therefore, basically you subtract them. 2 minus 3 is minus 1. This is equation 1. This is equation 2. And I take 1 minus 2 because why? I am getting rid of c. I'm eliminating the variable c. So therefore, minus 1 is equal to b. Back sub 4c. All right. And we get c equals 4 because we say 3 is equal to minus 1 plus c. Therefore, c is equal to 4. Therefore, the sequence general term is 2n squared minus n, because remember, b equals minus 1, and plus 4, because c equals 4. It's over there. Not a c. I wrote a c. It's a 4. Right? Whoops, not going to work like that. Come on. Is a 4. Now, can I work out T6? Yes, I can. That's 2 times 6 squared minus 6 plus 4. And you can work that one out. I've come to the end of my allotted 30-minute section. The next one we're going to do, I'm going to do a general formula, and then we're going to solve another one or two of these quadratic type of formulas. Okay, so the next one will be, let me just see. Yep, yeah. So that's where we are with the quadratic. Don't worry, we're going to do a couple more of these. Okay, cheers. Have a great one. Bye.